Well, I've just got this new three-phase inverter off of Banggood to do a bit of a review on, and I've just bought this three-phase dual voltage motor off of eBay. This is a 1 horsepower model. The inverter is 220 volt input, and it's connected to the motor 220 volt delta connection method. And I'm going to be using this setup on my Myford ML7. I'm replacing the actual single phase motor, which I had forward and reverse on. That was a good motor, but 3 phase is obviously better in a number of ways, and I want the option of variable speed and all the other things that go with VFDs. So the inverter has the same electronics as the one I got for my Chinese mini lathe. It's the XSY-81. And the only real difference is that the electronics are obviously housed in this different box, and the connection block is on the lower side here rather than the upper side on the other one. And this one has a screw-on cover, and it's all dead easy to connect up. The wires go through the ports at the bottom here onto screw terminals, and it's clearly marked with a sticker on the underside here. Plus it comes with very clear and easy to read operating instructions. You have this paper here which folds out, both sides with tables, drawings and instructions on how to actually wire the VFD up, set up the parameters, and also set up the block here for external controls on a control box or button system that you may like to add at a later date. And that's something that I will be doing at a later date, both on the Chinese mini lathe and the Myford here. I've got these really nice Momentary push buttons which I bought from eBay, and I've got some coming from Banggood as well. Very well made. They're actually made of metal with the switch mechanism on the back here, and it's 22mm cutout for these to be fitted into. So that's going to be a very good project when I get round to it. So the build and the actual construction of the VFD is very good. It's a good solid ABS plastic. On the back here we have the cooling aluminium fin section, and 2 computer type fans which draw air through that to actually take off the heat from the VFD. And that's something I really like about this one. Every now and again these fans will need cleaning from dust. You'll be surprised at how much dust they actually pick up in the workshop environment. And also in these fins it needs to be brushed out at some point. So it's basically just a case of taking the VFD off of wherever you've mounted it with 4 screws, and then you can actually brush and airline all this out. So Banggood do various models of this type of inverter, and it's very important to choose the one that you need. The 81, like I say, is the 220 volt input and 220 volt output 3-phase connection delta. Then you've got installation for the other 82s and 83s, which obviously you're not going to use. So it's basically this one here for basic operation wiring diagram, and that's what I'm going to be using. And for anyone that's interested, this is the label on my motor. And when I put this motor on my Chinese mini lathe, I had the electronic connection box at the top here. It's a very good motor to get, very versatile, because you've got the mounting positions in 3 different places, so you can have this actual wiring box either at the back here, like I've got it now, on the top, or on the other side. This is the Chinese mini lathe one, like I showed in the other video. So to actually change the position of that actual wiring box, it's not the actual box that comes off, it's the mounting feet which actually screw onto these spare positions. So it's basically take off both those brackets on the underside here, there's one either side, using those 4 Allen bolts, 2 on each. And then you can obviously screw it onto, or the brackets onto what side you like. If you were to use this top side here with the label on, you can actually unscrew the label and remount it in any of the other positions, so that label is always visible. So when you buy this motor new, you'll find it's normally got the wiring box on the top, so I've had to reposition those mounting brackets so that it's at the back here for the Myford ML7. Plus, when I got the motor, it's set up in star connection, and that's with these metal links here going across these 3 connections here. If you get a new motor, the third metal connector is normally hidden under the other 2 which connect these 3. So basically you just take these nuts off here, take off these links, and like I say, there'd be 3, and you join them then in this method, going across the terminals here, and that's delta connection. And it specifies in the instructions on this VFD that it must be connected in delta connection for this setup. It will still work in the star connection and it won't do any damage, but the correct orientation is delta. And if you do buy a second-hand 3-phase motor that's set in the star position, and when you take those nuts off you only have 2 links, it's very easy just to make up the third link using a piece of brass or thin steel plate and connecting all 3 in this method. So like I say, it's very easy to actually connect up this VFD. You have the earth, live 220 volt in, neutral 220 volt in, and then the WVU which connect up to the corresponding motor connections. And just remember, both the mains input earth and the 3-phase motor wiring output earth connect to the same terminal on the end here. So both the VFD and the actual motor are earthed to this terminal. So you obviously have to buy 3-phase cable for this motor, and I bought cable rated at 16 amps. So the 3-phase cable has 3 different colours, like a grey, black and brown, and then you have the earth wire. So there's 4 actual wires within that cable. And I actually found it better cost on eBay to actually buy a extension cable, 3-phase extension cable, and cut that one up rather than buying it by the meter. So the W, V and U wires connect up to the WVU input on the actual terminal block there. And on my other inverter, on the Chinese mini lathe, when I did it in that correct orientation, the motor ran clockwise. But I found with this one, when I connected it up exactly to the lettering on the actual motor, this one actually ran in anti-clockwise when the VFD was set in the forward position. But if that happens, don't worry about it. It's very easy to correct that, and all as you do is swap round any 2 of the input wires coming in, any 2 terminals, just swap those around and the motor will run in the opposite direction. So I just swapped these 2 wires here over, and that was correct then. So that's the connection box cover replaced with its rubber seal, and the motor's now ready to fire up. One thing I really like about these modern three-phase motors is that the actual motor is a completely sealed unit. There's no open end to the windings or electronics. The fan literally just pulls the air through the cover here, and the air goes through the fins that surround the motor and keep it cool. And there's no way that swarf or dirt can actually get into the electronics or windings. So it's a really great motor, and you can see why people choose a three-phase. Not only are they great for all the other benefits, but they're great being totally enclosed and can be used in a dirty environment. So I've connected the mains plug and switched the inverter on. And on camera the digital display shows up as flickering, but I can assure you off camera it's dead still. And one thing I do before I start using any equipment like this in the workshop, I always save the original instructions, copy that and save that onto my computers, and then I print out cards in A4, it's a very thin card. Use these as the working copy in the workshop. Then you've got the instructions safe, and it doesn't matter if these get dirty or whatever. So on the operating panel you have stop and reset, run, you have the speed control, forward and reverse, a display button. When the VFD is in the stop mode, you can actually press this display button here, and that becomes a jog button, so it actually jogs the motor in a very slow revs. You can actually set the parameters for that as well, how fast it goes in that jog mode, and you can jog it in forward and reverse. So that's very handy. And then you have the programming mode for programming the parameters, and the function data button, and that's the save button as well. The control panel can be removed from the VFD by this tab here. Push that one in and lift it up, and it comes out on a cable like that. I presume that you can actually get longer cables for this, so you can actually use the panel away from the VFD in another position. I'm not going to do that because I'm going to obviously make up another control panel with those buttons on that I showed earlier and use it like that, and that saves the actual control panel on the VFD from getting worn out. So straight out of the box you could actually wire this up and test it, and I know for a fact that this isn't actually set for this particular motor, but it won't harm it, so I'm going to turn it on now just to show you. But it is actually worth going through the parameters first, just to see that the inverter is actually set to the actual motor that you've got connected to it. This one's a 1400 RPM and it's 4-pole. So now I'm going to go into the parameters and change this one over to 4-pole. And this is referring obviously to the magnetic setup of the motor. So firstly I look up on the chart, there's many different parameters on here. I look up at P25, so that's parameter 25, which is the motor series selection. It's got 0 for 2 poles, 1 for quadrupole and 2 for sextupole. So it's actually giving you the option for 2-pole magnets, 4-pole magnets or 6-pole magnets. So firstly I press programming, and I want to go to P25. The quick way to do it is this: I'll go up to 5 and press the display on it. I'll take it to the next digit and press it up to 2, so it's parameter 25. And then you press the function data to see what the data is for that actual parameter, and it's set at 0. So that's wrong for this motor. That's for 2 poles. We want to go to quadrupole, which is 4. So then I jog this one up to 1, and now it's on a 4-pole magnet, and press the function data again, and that enters that amount. And now it goes to the next parameter, which is 26, which is the working frequency. If I press the function data on that, it's 50, which is correct for this motor as well. When you've done all the parameters that you want to change, or set all those, checked them, set them, when you want to get out of the programming mode again, you just press programming and it's back in the position for running. And I showed it on the mini lathe inverter motor setup, where I actually set the parameter for the jog speed of the motor. And like I say, when it's in the off position, you can press the display here, and that will actually jog the motor. You can hear the fan come on, and the motor will turn at a slow speed, or whatever speed you've set it to run at. And you can press the forward reverse, and it's gone into reverse there, and jog that one again back into forward, and it's ready to run again. And it's totally amazing the amount of different things you can actually do with the motor. You can change the velocity, descent velocity, you can change the actual torque, you can change all different speed ranges for which you want the motor to actually start off in, and how fast it speeds up, how fast it slows down. You've got brakes. There's so many different things. It's very interesting and really worth actually studying to see what you can actually do. And when you come over to connecting push buttons and other things to the actual low voltage block that I showed in there, the green one, that's low voltage. You can look on here, and P50 gives you the options for changing over to wire control stop or keying stop, keying operations, and stop keying. So it's actually gives you the options on the parameters for setting up these buttons and whatever you're using on it. And that's another thing. I've ordered a speed control potentiometer for external use from Banggood, and I'll show all these things in various videos if I get time. Another important thing to remember with inverters is that they do hold power even when they've been disconnected from the mains. Some of them have a warning on the front here to wait a certain period of time after disconnection before you mess about with any of the electronics. What I do with this one here, I turn it off at the wall and wait for the display to go off, and that's probably up to a minute before I know that it's safe to work on. And I am going to use my excellent labelling machine to actually put a warning on this one for anyone after I'm gone. Also, I've forgotten to mention earlier that the actual motor comes with a nice booklet which explains all the connections or whatever, so that's really good. And on the Myford ML7 I have taken off the old, it was a new single phase motor I had. I've only had it about a year with a reversing system. I've taken that one off, and I've made some heavy duty steel rails to actually move the motor forward a bit so that I can actually get the pulleys in line. And on the actual lathe, I'm not going to have the VFD mounted on the lathe at all or below. I've made a panel up above the lathe, so it's really handy to access, and I'll be screwing the actual VFD onto that one. And on the actual pulley, I'm using this tape taper lock pulley, one of the best pulley systems I've ever seen. I never knew they existed until a few weeks ago when I did the Chinese mini lathe. The actual way it works, you've got these two Allen grub screws which lock it all together when it's in position. If you want to actually take it off from the motor, you take those two out and then you screw one of them back in the top hole here, and that will actually release the pulley from the taper. On the larger ones you have to use quite a bit of force. That's clicked now, so that's come off, and then the whole assembly will come off from the actual spindle there. You might have to use a screwdriver just to prise the taper part open a bit before it actually slides off. So it's a really a good thing to have. You get these in all different sizes for all the ranges of pulleys. This one's 19mm with the wood rough key, so they actually mount on that one. One very important thing to remember if you're using these taper lock pulleys, with the taper, you've got to obviously mount it first. There's only one way it can go around to get the holes aligned. You can't put it in a wrong position, if you know what I mean. So that's it there. And then I put the grub screws in first and just lightly do those up so the taper doesn't fall out, and then you slide it onto the shaft like that, so it goes over the wood rough key. Now it's really important here, not many people mention this, but in the instructions it clearly says that you must have a gap between the top of the key here and the actual taper assembly. As long as there's a gap there, it's all right. That's so that when you tighten these two up and lock it onto the actual shaft, if there wasn't a gap there, the force can actually crack the taper part. So that's worth remembering. All as you do is get it into position like this, and then tighten the grub screws down, and that pulls the pulley onto the taper, and the taper is compressed on the gap here, and it actually locks onto the spindle. And I think there's torque settings for these actual grub screws, but I just do them up nice and evenly, quite tight, and that won't move at all, and it's ready to go. And they are very low cost for what they are. They're solid cast iron. I bought mine on eBay, and they're all a standard size or standard fitting. They have the numbers on. I can give the numbers for this one, for the taper and for the actual pulley. And like I say, that taper there will do a range of pulleys. And the great thing is once you've got the centre part, if you want to change the size of pulleys, you just buy the pulley to actually fit that taper again, and it'll go up to a certain size before it changes over to the next size taper. So I fully recommend this inverter, three-phase inverter from Banggood. I think it's well made. It's a very low cost for what it is, and it's very reliable, and I'm really pleased with that. And I've learnt so much about inverters and three-phase motors and that in the last few weeks. It's been very interesting. I love learning new things, and it makes life really worthwhile, being practical and doing this sort of stuff. And in my next video I hope to show this all set up on my old Myford ML7 and in operation.